So you get cloud data that corresponds to your temperature and pressure data. Now that's a little different. Dr. Weil has you just recording the low temperature and the high temperature for the day, but I want you to record the morning and the night temperature, along with the morning and the night pressure and the morning and the night clouds, so you can see the trend. Because sometimes the low temperature doesn't happen, at a given time in the day. So I think it's a kind of a better way to keep your data so you can really look at trends. Now if you want to think through some weather trends that might help you, did anybody play in the Kohl's Cup this weekend or camp out this weekend? Saturday, what did you notice about the weather on Saturday?
It was really cold.
Really cold on Saturday. Anyone who was outdoors on Saturday will remember it was pretty cold. How about yesterday?
It was a little warmer.
Yeah.
It
was closer to 50.
Yeah, it was maybe...
But it was rainy, so...
15 degrees warmer yesterday. And it was raining. So there's a key point. So notice from Saturday to Monday, the temperature was low on Saturday, high on Monday, right? And what did you notice about the rain yesterday? Was it brief thunder showers, or was it long, slow rain?
It was both.
Yeah, it was good.
A little bit of both.
Was the
More
sky
slow.
pocketed with clouds, or was the sky completely overcast yesterday? Okay, so here's the trend that we see. When it pretty much rains all day, maybe sometimes harder, sometimes lighter, but an all-day kind of rain, and the sky is completely overcast, you tend to see a warm front coming, which is indeed what we saw. So that all-day kind of rain that we saw yesterday with that stratus cloud layer is a warm front kind of weather. And we saw that, in fact, the temperature went up from that cold day Saturday to that warm day Monday when we had that stratus cloud covering long all-day rain. That is a trend that I want you to start noticing. If you see a lot of cumulus clouds, there's puffy, fluffy clouds that tend to be pretty separate from each other and not so evenly spaced. Those kind of clouds tend to show that a cold front is coming. So then you want to notice, well, do I see a trend of that temperature dropping? Okay, so now we've seen that temperature drop. What kind of clouds are we seeing in the sky? The magic of opening this window. I don't know if I can do it. But it's a really cold day today. And we've got definitely some cirrus.
Can you even see it with the camera?
Right. So we have up high in the sky very white clouds. Those are ice crystal clouds, cirrus clouds, and maybe even like a stratocirrus kind of cloud, because they're kind of a layer, and they're not just wispy, but they're more covering the sky. See, not to look at the sun, and I don't recommend that, but do you see how the sun is really shining through those clouds kind of in a halo? That might help us identify the clouds, and we'll look at some cloud identification websites, and then I'll email this to you so you can consult them if you see some clouds that are confusing and hard to identify. And I'll email you this Weather Underground site too.
Okay, so swipe up. Okay, crud. Okay, click on switch to password. Okay, now sign in options. Okay, click on the pin, which is the second option. Yep, center one. Okay, 1, 2, 3, 4. Well, it's the quick thing.
On YouTube for everyone.
Oh, great. Should probably change that.
You should change that.
Yeah.
1, 2, 3, 4 for anything. Please.
I'll give you some tips.
Bad code. All right, so let's consider some cloud viewing here and think about how you're going to start identifying the clouds that you see. So let me use my laptop to find the website I want. Is it this one? Oh, it's a long website.
Oh, it's showing. Oh. Please, no one look at my recent web pages.
Why?
because that will show you what I do.
I'm suddenly worried.
That's bbc.co.uk.
Oh, I'm hitting the wrong button. Kiwi underscore. Where's your oh, there it is. Kiwi underscore kids underscore loud underscore guide dot TV dot. Where's the dot? TV app. Yeah. Messed up something wrong. NASA.gov / SCOOL PDF Kiwi underline kids underline cloud.
Is cloud supposed to be capitalized?
Do they care about that? That's
It shouldn't. Is that when you're spelling school in? Or?
no, it's SQ.
Oh my god.
Alright, I will truly put all the capitals in it at once to be very precise. Oh, yay. Okay. So here is a great website which I will email you to help you identify clouds. And if we scroll down, we can look at some of the types of clouds that you will encounter as you study the weather for this month's long-term project. All right, so the three main types of clouds that we would see, and Dr. Weil has a fourth type of cloud, which he calls lenticular clouds, but they're really, well, that's not it. Those are not the three main types of clouds.
I think you're past it.
Dr. Weil calls the lenticular clouds their own type, but they're really classified, I think, as altocumulus. So, all right, well, the three main types of clouds are cumulus clouds. They tend to be fairly low in the atmosphere if they're cumulus clouds. Alto is a prefix that means higher than usual. Yes? You see, sure. Alto means higher than usual. And when cumulus clouds appear higher in the sky than usual, they tend to be smaller and closer together. And they also can help us predict what kind of weather we're going to see next. So we'll go over that in a few minutes. Cirrocumulus clouds are also even higher in the sky. And anytime you have cirrus clouds, the very highest of the three main types of clouds, what you see is a very white color with no shadow. If you have any areas of darkness in a cloud, it's not going to be a cirrus cloud, because cirrus clouds are made of ice crystals, so they never have a heavy accumulation of water droplets because they're made of ice crystals, so they're always a very bright white. So that's one easy way to tell if something is a cirrus cloud or not, is if it's completely bright white, it's probably a cirrus cloud. If it has areas of darkness, definitely not a cirrus cloud. But the cumulus clouds, altocumulus and cirrocumulus, are the types of cumulus clouds. And in fact, after we do this, we might take a look at the sky if we have time and see what we think. I don't think we have cirrocumulus right now because we don't see this kind of variegated or speckled look to the clouds. I think what we have right now are probably cirrostratus. Stratus is the second main type of cloud. Yesterday's long, extended, all-day kind of rain that came along with that warm front came from stratus clouds, where the sky is just an ambiguous gray with no real definition to the clouds. Stratus clouds just really tend to block out the sun entirely and cover the entire sky. But there are other types of stratus clouds, like stratocumulus clouds, which are kind of a combination of stratus and cumulus, where you see some definition, but yet they cover the whole sky, and they tend to be very low to the ground. Yes.
I was going back and check the fair up on the plane. We were going, remember we took off, we were going through stratus, the layer of clouds, and there were actually like 3 or 4 layers of the clouds.
Yes.
Like there was one layer, and then like a couple miles, like higher up would be another big layer.
Right, so the point there is that what we see, especially when the sky is pretty covered in clouds, is not all the weather that's happening. There's definitely stuff going on up above that we can't see, but on today where the sky is mostly or partly clear, we can see a lot more. Altostratus can be really challenging to identify. Stratus clouds tend to hang very low, and altostratus can often cover the whole sky but be up much higher. So you don't feel like the clouds are really low, but they do cover the whole sky, and that can be a hard distinction to make. And just with practice, you kind of learn, especially what kind of weather changes you see following stratus. You usually see warmer temperatures, a warm front. With altostratus, you may not necessarily always see the warm front, so that can kind of, in retrospect, tell you what you've got. Cirrostratus, do you see the kind of halo around the sun? Mm-hmm. And that's what we're seeing today. If we get a chance to go out and look, I was seeing kind of a halo around the sun. Cirrostratus tend to bring about that halo effect around the sun. So I'm pretty sure that that's what we're seeing out there today. Then we have rain clouds. Stratus clouds that are dark gray and or precipitating are nimbostratus. Nimbo is a prefix in that case that means dark or raining. And cumulonimbus clouds are cumulus clouds with that dark area, and those are the type of clouds that bring on thunderstorms. So we've got our all-day rain clouds, and then the cumulonimbus would be those thunder clouds. But both dark associated with rain kind of clouds. So, the other thing this site brings up is contrails, which are the trails that a jet would make. You see that streak there? When a jet exhaust, when a jet flies through a fairly humid area of the upper troposphere, you can get a contrail, but only when the weather's pretty humid, up in that part of the atmosphere. And they can persist for quite a while. They often spread out. But you might see those. Those are not the kind of clouds that you want to record because they don't predict weather as much. They're made by a jet, kind of man-made. So cirrus clouds tend to be this wispy. I saw one cirrus cloud this morning on my way here. Wispy hair-like clouds next.
How will contrails form?
So when the jet exhaust, which has water vapor in it, and it has dust and pollution in it, provides both some water, and there also has to be water in the atmosphere, and it provides the cloud condensation nuclei from the dust and pollution, so that any water that's up there is able to condense on it. Usually it's going to form ice crystals when it's up that high. And then get a cloud. Cumulus clouds, that would be your puffy cotton ball. I always think of the word accumulate because it looks like they're just like puff balls that accumulate in the sky. So cumulus clouds, they form during cold fronts mostly. So when you see cumulus clouds, you can expect dropping temperatures most of the time. You guys see that mostly in the summer, right? When you get those big cumulus thunderheads and you have a thunderstorm. After the thunderstorm, what do you notice about the temperature?
Drops.
Yeah, you can always get some relief from the summer heat after the thunderstorm because those cumulus clouds are coming in on a cold front. And we'll talk more about fronts and what that means and how you identify and why the type of cloud forms it does. So altocumulus, you'll just use these checklists to kind of identify the more confusing types of clouds. Do they look like really small cumulus clouds that are higher than a normal cumulus cloud? And it says if they're brilliant white, they're probably cirrocumulus. Altocumulus clouds tend to have, see how they're dark areas? That you don't see that with cirrus type clouds. Those dark areas would be altocumulus type clouds. And lenticular clouds, even though Dr. Weil classifies them as a whole fourth type of cloud, are really altocumulus clouds. And I think he's got a really good picture right here of some strange clouds. Altocumulus clouds tend to really be creative in the cloud world. They make some interesting shapes. We've got some pictures of lenticular clouds here. My kids were all like, I would hide if I saw that coming.
It looks like a giant saucer.
Right.
Like an
They're
alien
not
saucer.
storm clouds, though. They just, well, here, you can pass this side since it's a little smaller, let everyone see. But what happens is, in mountainous areas, you tend to get some air pockets of low pressure. And you guys remember that clouds are formed through adiabatic cooling when air expands, but nothing is there to give energy to it. So it cools as it expands. And when you find those air pockets of low pressure in mountainous regions, when moist air enters that pocket, it expands really fast. And those air pockets tend to have that lens type shape of a lenticular cloud. So then you get that, and you can see the really defined bottom of the lenticular cloud, and that's because that's just the boundary of that air pocket. So that's kind of why you get those really strange shapes. But I have never seen a lenticular cloud in real life. And I would definitely be concerned if I saw one, but they're nothing to be concerned about. Joshua?
They're actually forming on mountains. That's why you see some of them go on.
Try going to the Rocky Mountains or
Right.
like Devil's Peak. One time we were there on a cloudy day. Some really weird shaped clouds. I was just, this place is weird.
I grew up in the Appalachian Mountains, and I guess they're not high enough or don't have the right kind of weather to get that because I've never seen them. This is cirrocumulus, so a combination of cumulus and cirrus clouds. Remember that they're high in the sky, bright white, and you see rippling or striping. If you see, though, any type of dark areas, they're not going to be cirrus clouds. So you can compare it to some of these pictures when you're looking at clouds and you're just not sure. Fair, cold days have cirrocumulus, and I was thinking maybe we're seeing some of those because it's a fair, cold day. When they're combined with cirrus clouds, there's an indication that bad weather is on the way. So that might, in retrospect, tell us if we're going to see some bad weather tomorrow. Maybe we'll say, gee, those really were cirrocumulus. And if not, then maybe they're cirrus stratus. But I'm not entirely sure. Sometimes it can be really hard to identify the difference between stratocirrus and cumulocirrus. So stratus clouds, very gray, very low in the sky, like featureless, covering the whole sky. Also fog, mist, and haze are types of stratus clouds that you are just walking through when it's foggy, right down to the ground. Does someone have their hand up?
How do lenticular clouds form?
There's an air pocket in mountainous regions, just an area of low pressure. Have you ever been in a plane that just all of a sudden drops really fast and then stops dropping? I have. It's alarming. But you just like hit an air pocket and just drop. So there are air pockets of low pressure in mountainous regions, and then you stop and you go on, and the pilot's like, whoa, that was fun. Air pockets that tend to have that lens shape in mountainous regions. And since they're low pressure, when air enters them, it expands because of that low pressure area. And we know adiabatic expansion, when there's an energy coming in, is going to form the cloud. And when it forms a cloud in that air pocket, it makes that strange shape with that really defined bottom. So just air pockets that form in the mountains cause that. So stratus clouds, definitely not going to find definition. If you find definition in the stratus cloud, it's probably a stratocumulus cloud. So I would encourage you, altostratus can be hard to tell, but up higher, but still blanketing the sky. I would really encourage you to spend some time looking at this website, Overbright, and just get familiar with looking at the cloud pictures. Nimbostratus, nimbus is a dark kind of cloud. And then they go into a lot of different types of clouds that you really don't have to worry about. Cirrus clouds, bright white, wispy, like fine baby hair, and contrails, which you won't worry about because they don't predict the weather effectively. So, make sure this evening you take your first data point of PM temperature, PM pressure. If you have a thermometer and a barometer at home, you can use that. If not, use Weather Underground for the location nearest your house. I'll send out those links as soon as I get home, so you'll have that. And it stores data for a few days. I'm going to try to take pictures of the clouds near my house every morning and evening. Some days I'll forget, I'm sure, because, you know, that happens. If you get some interesting looking clouds and you want to take some pictures, feel free to stick them in the class Dropbox. Then if somebody goes away for Thanksgiving or forgets to look at the clouds for a day, they can take a look at what other people have done. So we can all kind of work together to encourage each other to keep up for a month, looking at the clouds and taking those data points twice a day, because I know it's really hard to do. And I get to do it every year.
Especially
so
when
you
it's
guys can
around the
work from home.
holidays and
Yes.
it's Thanksgiving.
I traveled last Thanksgiving, so I had to rely on other people to take pictures for me, which was nice of them. So definitely work on that. That can be a challenge. So next thing I want to do, we're kind of jumping around today, is I'd like everyone to grab the sheet I personally handed out. This is Module 7 Insulation Lab, and this half sheet of graph paper. So Module 7 Insulation Lab and a half sheet of graph paper. So as we're talking about weather, I need a bucket. So is anyone allergic to peanuts in here? Are you allergic to peanuts? Okay. Can you eat M&Ms? Okay.
I don't have the insulation sheet.
Okay, hold on. So, find it. Oh, there it is. So this is kind of an excuse for me to hand out candy, but, yeah. Okay. You're welcome. We'll need these sheets next week, so please don't lose them or forget them. Keep them in your folder. So we learned in our reading this week that insolation means incoming solar radiation. Yes? You do not have to eat them. Yeah, you don't have to. But there are Reese's Pieces or M&Ms. And don't eat them, but you can just apply them to your paper and feed them to your friends. Okay, your friend will touch them for you. That's not a fun thing. I'm sorry. I should have brought you beans or something. Safe, dry. Yes. So incoming solar radiation is what? Insolation. Incoming solar radiation. Chris, you look interested. You made eye contact. Please talk. Anyone? Right. So radiation from the sun comes to the Earth as heat energy and strikes the Earth. And it's one of the main causes of our weather, right? Incoming solar radiation. So if you lay out your graph paper, hopefully my battery's not going to die, we're going to examine how the angle at which sunlight strikes the Earth affects the temperature of the Earth. So what you're going to do, the flashlight will shine on your paper and it'll make one bright circle, and then it will make kind of a ring of lighter colored circles. But we're just going to circle the bright circle of light. So everyone needs to be ready when I shine the light to circle the bright area of light. Okay, okay, right there. So make a circle around the bright circle of light that this forms. That's kind of big. You might have cut off the side there. I'm measuring right from my knuckle. I'm trying to do everybody's from the same height. If I break my nail during this lab, then we'll have error. Alright, so while I'm walking around doing this, once you get your circle, I want you to count how many squares are in the circle, and then how many half squares are in the circle, and write down how many whole squares and how many half squares.
Mine's a little big.
Yep, just draw a circle of the brightest area. Yeah. So count whole squares and then count half squares and write down the number of each.
Well, it says whole squares plus half the number of half squares.
Right. To add them up, you need to do both. I mean, maybe you can do that.
Whole squares?
So right now, your number of whole squares and then number of half squares and then
On the
number of
graph.
anything you want. The lab sheet actually has a place to write it.
Mr. Died.
I'll be right there. Just count them up. Oh, sorry. My algorithm is that one. Okay, so count whole squares and number of half squares.
Did you just write the amount on the side?
Yeah.
Can you do it?
Okay, so now I'm gonna come back. I'm gonna use the same flashlight. So it's gonna be putting out the same amount of light, right? Hopefully, if my battery's not dying. But I'm gonna change the angle, and we're gonna see the area of light that's covered now. So I'll do it from the same height, but then the bright area. Yeah, we have the shadow problem. Maybe we should turn off the overhead light for this. Okay, I'm gonna hit the light. And now that you filmed that, you can turn off the camera.
Probably a good thing since it has, 2 minutes left.